Today I will be explaining the polar and rectangular representations of a sine wave. First, the Cartesian form, which is the most common form of a sinusoidal wave. Here we have the equation for the Cartesian form, where A is amplitude, the omega value is 2 pi over period, or 2 pi multiplied by frequency. T is time, and the theta value is the phase angle. Here with the positive theta, this indicates that this sine wave is leading the original sine wave. If the theta value were a negative, it would be lagging the original. The polar form of a sine wave is most important for multiplying and dividing the vector forms, where r is magnitude or the RMS value of the amplitude of the Cartesian form, and the angle is simply just the same as the phase angle given in the Cartesian form. Here is the equation of the polar form and how it is written, and here is a simple diagram. Converting Cartesian to polar. Here we have a simple sinusoidal wave in a Cartesian form where the amplitude is 10 and the phase angle is 50 degrees leading. Because the magnitude of the polar form is simply just the RMS value of the amplitude, r is equal to the amplitude divided by square root of 2, which in this case is 7.07. Because the angle of the polar form is just the phase angle of the Cartesian, this is simply just 50 degrees. Hence, the polar form in this example is 7.07 at an angle of 50 degrees. Rectangular form is most useful for adding and subtracting vectors. The x and y components of the previous polar form is split into imaginary and real components, where the a or horizontal component is classified as real and the b or vertical component is imaginary, indicated by the j here or sometimes I. Here is the equation of the rectangular form, and here is a graph showing the polar form from before split into the imaginary and real components of the rectangular form. Converting polar to rectangular. Here we have the same example as earlier, however this time in its polar form, where magnitude is 7.07 and the angle is at 50 degrees. Because the a and b components are just the horizontal and vertical components of the polar form, we simply use r cos theta to find the horizontal, which gives 4.54, and r sin theta to give the vertical, being 5.42. Hence, the rectangular form is 4.54, the horizontal, plus j, 5.42, the vertical. Don't forget to add the j here to indicate that this is imaginary. Thank you for listening.